Welcome to CCNA Security Chapter 1 lecture. This lecture is going to cover the basics of security, and really it's pretty much an overview of what you may have seen already in Security Plus course in the past, with a little bit of a Cisco slant to it. This chapter is just a good way to introduce your students to what they're going to be looking at, some of the concepts they're going to be trying to cover in terms of security in a network, how they're going to use some of the Cisco technologies and some of the Cisco features that are in the iOS to solve some of these problems that are shown, or these particular security issues that are shown in this chapter. We begin with a look at the evolution of network security. The main idea in this section is that security threats are increasing. I think that's easy to see. We've seen a move from what we call the hacker in the basement, the socially inept person who was in the basement who hacked because they couldn't get any other thing to do, to now nation states that are hacking for profit and for nationalistic purposes. Everything from industrial espionage to true cyber warfare. We've also seen a huge increase in the speed of attacks. This is a neat little diagram because we talk about some of the different items that have occurred on the internet. 78, the first spam attack. 88, the Mars internet worm, when an internet worm was accidentally created and released on the internet. But you'll notice back in the early 80s, or late 80s, mid 80s, you needed a huge amount of technical knowledge, and the attack tools were less sophisticated. As we move into our current time, 2010, 2012, the real problem is that there are free tools out there to let anybody perform denial of service attacks. Metasploit. There are even tools out there for Android-based devices that will automatically try to just pick a host, hit the button, and it will try to exploit that host and try to give you a root access to that host, or admin access. So the technical knowledge has gone down while the attacking tools have gone up. I think too, another thing we've got a huge increase in computing power. Computing power and also networking speeds for home users. Those networks that are there are available so that you can now, if you really wanted to do a denial of service attack, you can do it from a very high speed set of home internet connections. If you want to get access to anywhere, you have access to them. If you want to crack a password, you've got quad core machines with enormous amounts of RAM, very fast GPUs on graphics cards that can be actually harnessed to do encryption, cryptographic analysis. So the speed and the ability of the processors of machines have really changed the landscape for security. This is just a quick look at how the different, what we call basically firewalls, DEC packet filter. There's a stateful firewall, one of the first in '89, all the way up to NetRanger IDS, Snort, recently created in 1998, the free IDS that's available. IPS, you should know the difference between an IDS and IPS. Intrusion detection systems look at the traffic as it's going by, but don't really act on the traffic. They just may notify you. Whereas an intrusion prevention system attempts to make an actual change to the network to block the attack. Maybe shut a port down, maybe create a dynamic ACL that will stop an attack. All the way up through now, Cisco Security Intelligence Operations, ASAs, Cisco firewall modules for their switches, all the different technologies we have today for our networks. Different threats to our networks. Now, this particular slide doesn't show everything, but there are four basic classes we need to think about with our threats to our networks. One of them is a structured threat. Okay, so a structured threat is when someone is attempting to break into your network for a specific purpose. I want your source code. Okay, I want your social security number. I want your employee records. I want your customer database, so I can go to those customers and say, you know what? I can do this same price, but actually I can do 10% less for this product if you go with me. So that's a structured threat. That is, I want this, a particular item. There are unstructured threats. That's kind of like someone walking around the neighborhood rattling doors to see if a door is open, or we're going around the neighborhood looking around houses to see if something's available outside. Good analogies always kind of look at how typical crooks work and apply that to how they would work in a network. Well, an unstructured threat is you leave a set container of gas behind your house. Someone walks by, sees that container. It's got 6 gallons of gas in it. At today's prices, that's almost 20 bucks. They pick it up and walk off with it. So those are the types of things that are unstructured threats. I didn't really mean, I was just kind of scanning your network and I found this host open and, hey, look, there's your database. Woohoo, I can sell that to somebody. Now, add that to internal and external. Obviously, internal threats are those threats that are inside your corporate firewall. External threats are those that are coming in from the outside. Then we combine these. So we have structured external threats. That's someone outside your network with a specific purpose who's trying to break in. So structured external. Unstructured external. That's someone who's running port scans, ping sweeps, Nmap, Nessus, all these types of vulnerability scans, just playing around on the internet and then finding a hole, and then exploiting it. Then you have your structured internal threats. Those are very dangerous. That would be an example of someone who would possibly, let's say they literally interview at your business to get a job so that they then can get access to your internal network to get your source code. That's happened. That happened to Cisco. So structured internal threats and unstructured internal threats. I went and took this class on computer security. It taught me how to do some basic scanning. I'm going to scan the network and find out what I can find out. Oh wait, hey, I can get in the HR database. Hey, Joe's making more than me. What's going on? Those types of things. Those are unstructured internal threats. So again, the 4 possible threats: structured external, structured internal, unstructured external, unstructured internal. Out of all of those, any type of structured attack is very dangerous because the attacker has a purpose and a reason for attacking your network. A lot of times they're being paid to attack your network. Okay. Now here we're just showing basic encryption. This would be encryption algorithm using one key on both sides. That would be symmetrical encryption, if you can remember symmetrical and asymmetrical encryption. These are ways to protect our data. We can use GRE tunnels, which unless you use IPsec inside of a GRE tunnel, there's really no encryption there. Site-to-site VPNs, SSH, MPLS, SSL VPNs, which are one of the newer items. Get VPN, group encrypted transport. Okay, all different items and ways we can encrypt our traffic. So what are some of the drivers for network security? Well, one of them is, and it shows all the war dialing. Do you want to play a game? That's straight from war games. Kevin Mitnick, all these different things that's shown here. Script Kiddies hacked the Embassy News Twitter account, posting fake updates related to a terrorist attack. That was in 2011. Okay, so some of the big drivers are, number one, there are a lot of attacks going on. That's a big thing. There are a lot of now laws in place that make it will cause a fine, or will cause a company to lose money, or cause a company to have to cover the cost of helping their customers if there is a breach of data security. Okay, so here's the first Melissa virus, or an email virus, was March 1999. Here's the actual email that sent it. Here's the first worm, which occurred in 1988. First spam. Here's the actual spam message that went through. Okay, would you not? That wouldn't be good. First denial of service attack. A mafia boy was sentenced to 8 months because he did a denial of service attack against some major sites in February of 2000. So these are drivers. Okay, we have some different areas that we can get jobs with network security degrees: network security engineer, information security analyst. One of the things that you do want to also think about is a lot of universities now, instead of calling it network security, they're calling it information assurance. Be aware of that. Same thing, it's just a different name that they've started to use. Here's some security organizations that are out there. First, CERT, InfoSec, SANS, Mitri, CyberWatch. Okay, there's one. There's all different types of groups out there. And those are great places for you to go find information. In fact, the first lab for this particular class just has you going out, looking at some of these sites, looking at some of the latest vulnerabilities and exploits, looking at what's going on the security landscape. Alright, there's CERT. Moving on through. Okay, here's some of the different certifications that are available through ISC. Okay, System Security Certified Professional, CISSP. That's one that's about 2 miles wide and a ½ inch deep. Very good certification to have, especially if you're in management, because it will give you a premium in terms of salary. Here's some other things we can get. Obviously, updates on RSS feeds and everything on our iPhone and or approved Android device, just in case you happen not to drink the Kool-Aid. Some of the different things, network security domains, risk assessment, these are out of the CISSP certification, 12 domains, risk assessment, security policy. These items we'll talk more about, but really at this point you should have had a Security Plus course that covers the information that you would need in each one of these. Okay. Security policy. One thing I will say about all of our network security that we do, our information assurance, we drive it with our security policy. In other words, our security policy is the center of our entire process of securing our networks. We use that defined security policy to be able to secure, test, monitor, and improve our networks. And that's really what they're going through here. Here's some of the Cisco Secure X architecture, scanning engines, delivery mechanisms, security intelligence, okay, how to distinguish good traffic from bad traffic, policy management consoles, and next generation endpoints. Okay, so it's kind of this little bit of Cisco marketing to talk about their architecture for doing security on the network. And here's some different products on the Edge and Branch ASA 5500s, which we actually have an entire section on. Secure Email, Ironport. They bought Ironport, and so you can buy an engine from them. Secure Access using Identity Services, Network Access Control, or NAC. Secure Mobility with the ASAs or the IPS software for your wireless, or the AnyConnect if you use their AnyConnect VPN client. And in Secure Data Center, we've got the couple things: ASA 5585s, the Cisco 6500 ASA service module, which is really just an ASA on a blade that you plug into a 6500, and the virtual switch gateway, the Nexus 1000V, which is a virtualized Cisco switch that you can put into the VMware vCenter environment. Now, security policies. We could spend an entire 2 days on just security policies. But the big thing is security policy has to meet the needs of your organization. What? I always tell my students, the level of security has to meet the level of threat. Also, the level of security has to meet the level of regulation. If you work at a bank, your security policy is going to be very different than if you work at a school. If you accept credit card payments online, your security policy is very different because of PCI compliance than it would be if you did not. So these are the types of things that have to be placed into your security policy. Now let's just talk about some of the different, I guess you would say, attack types or vulnerabilities that could be placed on your network. We're not going to go through all of the slideshows, but here's a virus. Okay, a virus. Now, a virus is typically a malicious piece of software that's attached to another program. It needs you to execute it. All right. So, in other words, typically when we say a virus, it is a piece of malware that requires user intervention to execute. That's different from what we're going to call a worm. Okay, and here they show you how viruses spread. Okay, here's some of the different viruses that are out there. Okay, that's one of the new things in this CCNA security curriculum. There are little more information boxes that you may not realize you can click on. So make sure you click on those and see those. Here's some of the different viruses. You know, for a human virus, you've got to cough and it has to be spread. On a computer virus, it's spread by flash drives. Still, typically with viruses, we say you have to have human interaction. Worms, however, worms are a special type of code that will replicate themselves. Obviously, we've had a bunch of them. Many of them were based upon buffer overflows and or RPC call errors or problems. But here are some of the different ones that have been out. The Melissa Morris worm in '88, Melissa Love Bug, Code Red. One of the interesting things about Code Red is there was a patch for Code Red for a very long time before Code Red actually hit the internet as hard as it did. In other words, there was a known patch and people didn't patch it. what we've seen in computer security is we've seen a huge decline in the amount of time between when a security vulnerability is found and the exploits found in the wild. In other words, we're seeing a lot more zero-day exploits, which are, there's no patch for this particular exploit and it's out in the wild already. With these earlier worms, if people had patched their systems, it would have had minimal effect. But because they didn't, the worms were able to attack their systems. As we moved into the modern day, it's much harder for you to patch for these exploits because they're becoming zero-day exploits. Okay? So a worm, unlike a virus, can propagate itself. And that's really the major difference between the two. A virus has to have a user to propagate, whereas a worm can propagate itself. So worms usually probe. They look to find other computers that are susceptible to their particular piece of code. They exploit those hosts. They persist to make sure if the machine is rebooted. In other words, they write themselves into the registry entry so they can restart themselves. And then they start propagating again. Okay? And then if they want to, they can do denial of service attacks. They can start deleting files on the system. All different types of things. Okay? Here's Morto 2011, scans Windows listening for 3389. That's why I moved my particular machines running remote desktop off of 3389 to a different port. And it is pretty nasty. Alright, Trojan Horse. It is a piece of malware that impersonates another piece of code, just like the Trojan Horse story. They thought it was just a big wooden horse that was being given as a gift, and inside, lo and behold, all the soldiers from Greece. So that's a Trojan Horse. Okay, multiple different types out there. Not going to go through all those. Now, how do we mitigate these viruses, worms, and Trojan horses? Well, typically what we do is we patch. Okay, and if we have our patches up to date, we have our machines blocking the most well-known viruses, worms, and Trojan horses. We then use antivirus software, and a lot of these antivirus software have heuristic software that allows them to see any piece of code that is acting like a worm or a virus, and then they will quarantine that. We can also have on our networks, we'll talk about IDS and IPS, that can look for suspicious activity. But for the most part, we patch and we use antivirus. Now, worm mitigation, if we do get a worm on our network, we try to contain it by quarantining those particular systems. You can shut off VLANs, you could create ACLs to block the worm. A lot of different things you could do to actually quarantine the worm. And then we try to inoculate or treat the machines that are infected and get them clean. Here again is a couple ideas. We could go in remote access, we could do ACL port blocks. That's a great example of what happened to us. One of the major worms we had was blocked completely at the edge of the network, but if someone walked in, had it on a floppy, and this was a while ago, and released it into the network, and boom, no matter what you do at your ingress ports on the internet, you're not going to stop that. There's all different types of attacks that we have. Okay, impersonation, eavesdropping, denial of service, packet replay, man in the middle. All of these are common attacks that are found when you look at Security Plus. So reconnaissance, just trying to look around and see what's going on, doing ping sweeps, finding live systems, enumerating your systems to find out what type of operating systems are there, what patch level they're at, what particular code or software is running on them. Packet sniffers, okay. Packet sniffers are bad because they can sit there and look at all the traffic between different hosts. Here's Wireshark, it's a free one. If you use make your network a switch network, that's not going to be a big issue as long as you use some type of port security. Here's all our different type of internet, whois queries, ping sweeps, port scans. All of these are reconnaissance attacks that give us information. Now, once we have reconnaissance, our next item would be, if we were a hacker, would be to try to gain access. So we're going to try to exploit the system. If you take a certified ethical hacking course, you will learn the different phases of attacking a network, and they pretty much follow along with what is here. Reconnaissance, then we do enumeration, then we do some actually exploitation, Alright, we can do a password attack. We just do a brute force, try to guess your password. You can do as far as access, you can do a trust exploitation. System A trusts System B, but System B is not very well secured. So we'll just break into System B, and since it's trusted by A, guess what? We're in. We can get into System A. Port redirection, okay, where we try to exploit trust relationships, try to make the system forward traffic to an incorrect host. Man in the middle, okay, the attacker appears to the local host to be the local router, when in fact it's not. It's just a local machine. The host sends all this information to the attacker, then the hacker or the attacker sits in the middle, and the victim never knows what's going on. Buffer overflow. This used to be and still is one of the most common ways to gain root access to a machine. Just find a program that has poor buffer control, fill it full of junk. It'll spill over into a privileged portion of the memory. Boom, you're in. You're able to have and exploit that. Deliver yourself an administrator account or be at the system level prompt. So, access attacks. Okay, here's some of the ones talked about. Denial of service attacks. These are big. I'm just going to take you offline. You're my competitor. I know that one of the biggest set of orders that ever come are at Christmas, so I take you offline at Christmas, you lose millions of dollars, you go out of business. It's happened. It's happened many times. Denial of service attacks are very hard to stop. Denial of service, if it's just one machine or one or two machines sending pings to the server so it can't respond, that one you can fix because you can block that one particular system. But if it's a denial of service attack and someone gains control of a botnet, they can then tell all these infected computers from all over the world to attack a site. It's not a whole lot that can be done about that because at the very least it's going to block, it's going to fill up the ISP pipe for that particular business. Okay, it's qzbank.com, and it won't be able to respond. Now, the ISP and the qzxbank.com could put in ACLs on the routers, but it's still going to be affecting their traffic. So distributed denial of service is very tough to stop. Ping of death is just a malformed ping packet. A Smurf attack is when you send an ICMP echo request to the broadcast of a network from the spoofing the host that you want the network to ping, and then all of those machines will send back ICMP echo replies to the victim. The victim never sent the original ICMP echo request. That one was being spoofed, and boom. You can actually fix that by turning off IP directed broadcast on your router. And then send floods. I send a whole bunch of sends. The server sends back send ACKs, and then it expects to get an ACK from me. Okay. Well, I've spoofed all these sends. So when the web server sends a send ACK back out to all these hosts that I've spoofed, they go, I don't know what this is, and they drop it. Okay. And they never send the ACK back. That leaves the web server with a bunch of half-open three-way handshakes. There are ways to mitigate this using timers on the half-open connection table, using the ASA to block the actual half-open connection or rate limit the half-open connections. So that is a TCP send flood attack. Some of the symptoms of a DOS attack are very slow network performance, unavailability of one particular website instead of all websites, inability to access any website if it's your site that's being DOS'd, and dramatic increase in the number of spam emails. So that would be a mail bomb, where they're using mail to continuously DOS your system. So, what can we do? How can we stop these attacks? Well, one thing we can do as far as reconnaissance goes is encrypt our traffic. If an attacker is sitting between router A and B and we encrypt that traffic with AES, they're going to have an extremely hard time grabbing that traffic and decrypting it. The hope is by the time they decrypt that traffic, the traffic would be useless, or the information would be useless. Use anti-sniffer tools. There are tools out there that actually tell you if something's in promiscuous mode. Implement switch infrastructure if you inside your network on the switch side, on the LAN side, and use an IPS and firewall. Other network ways to mitigate network attacks. If you want to mitigate password guessing, go to your users and give them a strong password security. Tell them, uppercase, lowercase, alphanumeric. Then give them a way to do it. Say, take the lyrics of your favorite song. Okay? Or, it was the best of times, it was the worst of times. Now, if they take that and go, it was the best, ITWB, 8888 or 8850, pound 1. Boom. They can remember that. So tell them to create a little saying and then use the first letter from each of the words in that saying as part of their password. That's something you can do easily. You can put in ASAs and ISRs with the firewall feature set. Use anti-spoofing technology. You can implement physical access, control physical access, patch your systems. You know, every second Tuesday of the month, Microsoft will have patches released. Patch your systems with those patches. Okay. Develop a good security policy. Use antivirus and update your antivirus. That's a big thing. So many people don't update their antivirus. You should be updating your antivirus at least every day. Maybe every other day at most. But I just set mine up to do it every single day. Cisco also has some, this is a little bit of marketing speak here, but their network foundation protection framework, they talk about how they control how they can secure the control plane. Okay, and the control plane is that part of the Cisco device, router and switch, that handles device-generated packets required for operations such as ARP request, routing protocol exchanges, those types of things. The management plane is management plane traffic used to get into the device to manage the device. Now that could be in-band, which is on the actual network, or out-of-band on a special management network that carries no network data, or no actual data. It's just a management network. And then the data plane is the plane that actually forwards traffic, so incoming, outgoing IP packets. So, to secure the control plane, we can use Cisco Auto Secure, which we will actually run a little bit later, which is a one-step lockdown tool that goes through the CLI and turns off unneeded services. Have to be careful with it though, because one of the things it will do is turn off some services that you might need in some environments, so be careful with that. You can do routing protocol authentication, which you should be doing. And you can also implement control plane policing, which is a special set of features that allows you to control what the amount of traffic that hits the control plane, the quality of service of traffic going to control plane, those types of items. It's really beyond the scope of the CCNA security, but it is mentioned here if you want to read about it. Management, we're going to do a lot about the management plane. We're going to talk about login and password policies on the command line. We're going to talk about local databases. We're going to talk about remote radius databases. Your legal notification, your banners. Make sure your banners will pass legal muster in your state. Make sure they don't say welcome. They should say do not enter. Unauthorized access will be prosecuted to the fullest extent of the law, pursuant to whatever. Have your lawyer look at your banner. That's going to be one of the major things that you can use in court and say, Your Honor, this person knew they should not have been in this router and they were in it anyway or attempting to get into it. Ensure the confidentiality of data using, especially with management, using SSH instead of Telnet. We can talk about role-based, authorized actions. All of these items we'll talk about as we move into Chapter 2. Last but not least, these items on the data plane you're most familiar with already. We use ACLs to block traffic. We can reduce the chance of DOS attacks using ACLs. We can mitigate spoofing attacks using things such as port security, DHCP snooping, dynamic ARP inspection, IP source guard. Okay, that'll help prevent spoofing IP addresses. All of those we'll talk about again also in Chapter 2 and 3. So, that's it for Chapter 1. Don't forget our 4 major types of threats. Internal and external, structured, unstructured. Those are major items you need to know. Be aware of what a virus is. You know, a virus is a piece of malware that needs user intervention for replication. A worm is a piece of malware that can replicate itself, can propagate itself. A Trojan Horse is a piece of malware that is impersonating some other program or software. Those are the main points of Chapter 1. I hope it's been useful. If you have any questions, please let me know. Thank you.